What if I told you that some ants operate a tiny emergency room, diagnosing infected wounds and treating them with their own antimicrobial cocktail? Meet Megaponera analis, a remarkable ant species that hunts termites and has developed a sophisticated system of battlefield medicine. In their world, injuries are common, and without proper care, most wounded workers don't survive. When an ant gets injured, the risk of infection skyrockets. Once the cuticle is breached, microbes can flood in, turning a small wound into a life-threatening situation. This risk is especially high for social species like M. analis, which live in close quarters. Researchers discovered that these ants can actually identify when a nestmate's wound is infected. They then switched to a more potent treatment, utilizing secretions from a special organ called the metapleural gland. This organ is rich in antimicrobial compounds and proteins that target infected wounds, drastically reducing mortality rates. In controlled experiments, scientists created tiny wounds on ants and exposed some to soil microbes while others received a sterile solution. The results were striking. Infected ants carried significantly more bacteria and exhibited a different microbial profile, with notable spikes in harmful bacteria like Pseudomonas, Klebsiella, and Burkholderia. The survival rates of infected ants improved dramatically when they were with their nestmates compared to when they were isolated. This social care is crucial. It's clear that being part of a colony can save lives. Among the isolated microbes, Pseudomonas aeruginosa emerged as a major killer. When applied to a wound, it drastically increased mortality rates. However, when infected ants were returned to their colony, their chances of survival surged as their nestmates sprang into action. The care these ants provide isn't just random grooming. They first lick clean the wound and then deliver metapleural gland secretions either from their own glands or directly from the injured ant. What's fascinating is that these treatments are more frequent and last longer when the wound is truly infected, particularly during that critical 10 to 12-hour window after injury. If researchers block the metapleural gland, the infected ants face very high mortality rates. But when the gland is left open, many ants survive. This provides strong evidence that the secretions themselves are life-saving. Interestingly, the ants seem to smell illness. Infected ants show distinct changes in their cuticular hydrocarbon signature, particularly in alkadians, which are used for chemical communication among ants. These odor shifts likely serve as infection cues, triggering targeted care from their nestmates. Chemical and proteomic analyses of the metapleural gland secretions revealed a remarkably complex formula. 112 organic compounds, including various alkaloids and antibiotic-like structures, as well as 14 carboxylic acids that likely lower pH, making it a hostile environment for bacteria. On the protein side, 41 proteins were identified, several known for their antimicrobial or wound-healing properties, along with candidates that could disrupt pathogens. In lab tests, these secretions slowed the growth of Pseudomonas by over 25%. The parallels to human medicine are striking: rapid cleaning, targeted antimicrobials, and escalation of treatment only when infection is detected. It's efficient and resource-preserving, and it works. The kicker? Pseudomonas aeruginosa is also a major cause of human wound infections, particularly in combat injuries. Studying these ants could inspire new antimicrobial strategies, especially in an age of rising resistance. So yes, some ants are running triage, diagnosing infections with chemical cues, and treating them with a bespoke multi-compound antimicrobial blend. This is Social Immunity, nature's group health plan, showcasing a stunning example of how life thrives in the natural world.